discretization. Certain machine learning algorithms expect your data to be in categorical format only. For example, you have, say, decision tree algorithm, which expects your data that you provide to that algorithm, to that machine learning algorithm, to be in categorical format. So you need to convert your numerical data into categorical format. Okay. And one way is called as binarization. Okay. First, let me talk about discretization, then I would certainly get into binarization. And if you were to convert your numbers into categories, then it would be called as discretization. For example, say you have a column called salaries, $6,000, $8,000, $12,000, $2,000, $3,500, so on and so forth. Now, if you come up with certain rules, such as salary less than $4,000 means low income. Salary greater than $10,000 probably means high income. And if your salary is in between $4,000 and $10,000, then probably it is medium salary. So if you look at this, 6,000 is in between 4 and 10,000, so that means it's medium. 8,000 is in between these two, so you say it's medium. 12,000 is obviously greater than 10,000, so you say high. Then 2,000 is less than 4,000, you say low, and 3,500 is also less than 4,000, so you say salary is low. So the numeric data is now converted into categorical data. And how many categories do we have here? We have 3 categories. Medium is one category. Okay, medium is one category, high is another, and then you have low. So you have 3 categories here. Medium, high, and low. There we go. So we have 3 categories on there. Okay. Instead of 3 categories, if I aim to have only 2 categories, then the discretization is going to be called as binarization. Bi means 2. Uni means 1. Bi means 2. Tri means 3, so on and so forth. Uni means 1, bi means 2, tri means 3, so on and so forth. And here we have binarization. Bi means 2. So if you were to look at salary, if you look at all these salary values, and if you look at the categories here, if you have a condition like this, which says that if the salary is less than 7,500, then it is low. And if the salary is greater than probably 7,500, it is high. If you have this kind of representation, then look at this. Less than 7,500 low, greater than 7,500 high, 12,000 is greater than 7,500, you put it as high. Then 2,000 is less than 7,500, so you say low. 3,500 would be low because it's less than that. Usually, the equal to sign would be given to the less than. Okay, so that means if the salary is exactly 7,500, it would still be called as low. Here, if the salary is, exactly equal to $4,000, then you say low. Okay, that is how you represent. Sorry, this should have been 7,000 here, and the $sign should have been there. Anyways, these are subtle, mistakes, I should say, from our side. Next, you have rounding. Rounding means if you have, for example, 1.5, 1.68, 1.32, so on and so forth, some numbers, whatever be that column, doesn't matter. Rounding off means you convert all of these to the nearest zero. 1.5 would probably be 2. 1.68 would probably be 2. 1.32 would be 1. This is one way of rounding off, friends. Meaning, if you have any number, wherein if you have one, after decimal, if you have 5 or more than 5, you can round it off to the nearest ceiling value. Nearest ceiling value. But then there is another variant of rounding wherein you get the floor value. What do you mean by floor value? In 1.6, the floor value happens to be 1. In 1.5, the floor value happens to be 1. In 1.32 also, the floor value happens to be 1. So these are all floor values, and these are all the ceiling values. So you have the floor values on one side and you have the ceiling values on another side. Okay. So this is one simple way of rounding off, which would actually convert your numerical data into some categorical. Or discrete, I should say, because that would then appear as count. Then we have binning or grouping logically. Binning or grouping is very, very similar to what we have done this. Actually, those are the same terms. What are we doing? We are creating some groups. You're saying that the minimum salary to 4,000 should belong to a specific bin or a group called as low. Then from 4,000 to 10,000, you put that into high. Oh, sorry, medium, my bad. Into a bin or a group called medium. And then any value which is greater than 10,000. So you can as well create a group such as 10,000 to the maximum value. You call this as high. So what are you doing here? You are trying to create different bins or different groups. Okay, we are trying to create different groups or different bins out here. This is called as binning or grouping. And when you create binning or grouping, you can either have a fixed width of bins or variable width of bins. Fixed width of bins meaning you might say that, you know what, from minimum value to 2,000, then from 2,000 to 4,000, then from 4,000 to 6,000, or rather than minimum, I would say 0 out here. Okay. Then 6,000 to 8,000, In that way, you create 2000 bins. The range of every 2000 would be a specific bin. This is called as binning or grouping. Okay. So you can either have fixed width binning this way, or you can have something called as adaptive binning. In adaptive binning, you leave it to your algorithm to create different bins. Okay. So for example, rather than saying that I want all this data to be divided into 10 bins or 3 bins, rather than saying that, you can say that, you know what, let the algorithm decide on how many bins would be needed. Because if you're going to force fit and say that this entire data that we have should be put into 3 equal bins, if you leave it to your algorithm will logically divide that. How is it going to divide? How is it going to work is something that we will learn when we practically work on the Python program. Okay. Next. When it comes to discretization, within discretization, we have all these techniques: binarization, rounding, and binning. Right? So technically speaking, binning is nothing but discretization. It's a kind of discretization. Okay, wherein you have fixed width binning and adaptive binning. These are the two techniques that we have. All right. Are we done? No. Because certain other algorithms, such as your regression models, or there is an algorithm called as KNN, right? These kind of algorithms cannot deal with your categorical data, and they expect your data to be in a numeric format. They expect your data to be in a numeric format. So when you have categories, you might want to convert them into numbers. And this process of converting your categories into your numbers is called as encoding. There is one type of encoding which is called as binary encoding or one-hot encoding. Okay. And let me also tell you one thing. Okay. So I would want to just quickly open a specific mind map, and I want to show you something interesting here. By no means I want to scare you all. By no means I want to do that. Okay. But then when it comes to outlier analysis, we have univariate, bivariate, multivariate. Okay. And then you have time series outlier detection. Then how do I remove the outliers? There is something called as top encoding, bottom encoding, so on and so forth. Okay. Then when it comes to categorical to numeric, you have binary, or let me say numeric to categorical, which we have done. We have discretization, equal width, equal frequency into 2 ad hoc way of doing that. You have decision tree discretizer. Okay. And then when it comes to categorical to numeric, you have a bunch of these which exist. Then there is something called as data reduction. And then you have something called as imputation, right? There are a few other data cleansing techniques. How do you delete irrelevant columns? How do you delete the irrelevant rows? Then what are the various feature selection techniques that exist, and what are the various feature transformation techniques which exist. This list is going to just expand. Okay. So whenever I personally do consulting, or when I actually work on certain projects, in the due course, through my research, I come across different techniques and I keep adding to the branches. And do you know what? We are coming up with an exclusive 30-hour program only on data pre-processing and data ingestion. Data ingestion means pulling the data from various sources. 30 hours of only data pre-processing. That is the amount of time that you spend in analyzing your data. Okay. And for data science training, the core data science training, we don't usually get into that depth. Okay, because there are far more concepts that we need to focus upon. But then once people are trained on data science, once they start working on the real world data, then probably all these data pre-processing techniques make more sense. You'll be able to understand and appreciate the concepts in a better manner. Okay. Back to our discussion here, which is binary encoding or one-hot encoding. So the point that I'm trying to drive is majority of those which I've listed down, I would bring it into the discussion here, and you all will learn that. But every nook and corner probably will not be in a position to cover, because there are a lot of other algorithms which would take the precedence. So back to our discussion. What do you mean by binary encoding or one-hot encoding? Suppose there is a column called gender. Okay. And in this column, suppose you have male, female, male. In that way, say you have male and female. Assume that there is no other gender, there is only male and female for our understanding. Any column or any feature which has limited values, any feature which has limited values would be called as a factor. And whatever are those limited values that you have would be called as levels in the factor. So gender would take either male, female, or a few other, varieties or categories. But then the point is, the number of levels or the number of unique values which the gender can take would be limited. You cannot say allow infinite variety of genders. No. Since the values are limited, okay, this would be called as a gender. Sorry, factor. My bad. This would be called as a factor. And how many levels do we have in this? 2 levels. What are those? Male and female. So this happens to be a factor which has 2 levels, male and female. So within one-hot encoding, you add those 2 levels. You say it is male. You say this is female. Male means 1. It's not a female. I mean, this person is not a female, sorry. And if a person is female, you put a 1, 0 here. If a person is female, you put 1 against female and 0 against male. If a person is a male, you put a 1 against male and 0 against female. This process is also called as binary encoding because you have 1 0 1 0, right? Using 1 and 0, you are able to represent a specific entry by 1, 2, 1 or 0, right? It's by binary encoding. Why is it called as one hot encoding? Because for any entry that you take, you will have only one. Rest all will be zeros. Now, let me take another example. And this time, let me take make of car. Make of car. Okay. Say you have petrol variant, diesel, CNG, LPG, diesel, petrol, so on and so forth. Right? When you look at make of car, and if make of car, what other makes do you have? Probably an electric variant, probably something which runs on solar power, or maybe something which runs on water. But beyond that, you will not have unlimited makes of car. The make of car would be limited. You'll have limited values here. And if you look at these limited values, there are how many unique values here in this data set? Petrol, diesel, CNG, and LPG. These are the 4 variants. So make of car would be called as a factor. And this has 4 levels within that. So we have petrol, we have diesel, we have CNG, and we have LPG. Okay, we have these 4 variants. Since this is petrol, you put a 1, rest all will be zeros. So 1 hot, only one value is 1. Diesel, you put a 1 here, rest all will be zeros. For CNG, you put a 1, rest all will be zeros. For LPG, you put a 1, rest all will be zeros. For diesel, you put a 1, rest all will be zeros. For petrol, you put a 1, rest all will be zeros. This is how you convert your categorical data into numerical. You convert your categorical data into numeric data using one technique which is called as binary encoding or one-hot encoding. Next. Okay. We have binary encoding or one-hot encoding. If you have education level, and if you have, say, high school, bachelor's, master's, doctorate, if you have 4 different levels, unique values, 4 unique values, then this would be called as a factor. With how many levels? You have 4 levels. If you have 4 levels, how many dummy variables are we creating here? These are also called as dummy variables. Different levels are taken here. So you have, if you have 4 levels, you have 4 variables. Since this is high school, you put a 1, rest all 0. Bachelor, you put a 1, rest all zeros. This is high school, again 1, rest all zeros, so on and so forth.